we're going to learn how you test a solution to a system. Now, this goes back to when we have a system, the solutions, there can be one solution, there can be no solutions, there can be infinite solutions. Most of the systems that we work with are going to have one solution. And it's really good for us to be able to know, okay, if I come up with this one solution, how do I check my answer? How do I test and see if that is in fact the solution? Okay, and it's really important that we're able to check because that means that we never have to worry about whether our answer is right or not. So, in order to test if an ordered pair, okay, remember that the solution to a system is an ordered pair, that's this, right? It's a 3, 5, or negative 2, 1, or whatever it is, right? But it's an x and a y value. In order to test if an ordered pair is a solution to a system, here's what we do. We take that x and y value and we plug them in. Plug the x and y value in. And what do we plug it into? Into both equations. Remember, a system is 2 or more equations. In Algebra 1, we just work with 2 equations. Okay, we can plug the x and y value into both equations. It's got to be both. Okay, and the reason we have to plug it into both is because it could be a solution to one equation and not the other, in which case it's not a solution to the system. Because if you remember, right, a solution to a system has to be on both lines. So that means it's going to plug in correctly into both equations. Okay, so the point, the ordered pair, the point is a solution. It is a solution if it makes, again, both, right, got to be both, equations true. Okay, so we're plugging it into both. It has to make both equations true. What does that mean, true? Okay, true. Here's a true equation, 3 equals 3. Here's a true equation, 0 equals 0. Here's a true one, -1 equals -1, right? Those are true equations. Okay, now, a not true or false equation looks like this. 5 equals 3. That is not true. 5 does not equal 3, right? -4 equals 0. That is not true. Those are not equal. -3 equals +3. Also not true, right? So we need to be able to plug this point, our solution, into an equation and get an answer that looks like this. Okay, so we're going to do 2 examples. Okay, and you might get a question like this. Is 2, -4 a solution to, and then here's the system. Is it a solution to this system? Now soon you'll be able to find the solution yourself, and then check your own answer. Okay, but right now I just want to know, is this a solution to this system? Okay, now here's what we have to remember. This number is always the x, this number is always the y. Okay, I'm going to use highlighter so you can see a little bit more clearly, right? This is the x value, 2. So I'm going to plug in that 2 for x, right? And then this is the y value. How do I know? Because it's always x first, then y, right? So the first number is always the x, the second number is always the y. I'm going to plug that -4 in for y over here and over here. Okay, so let's take a look what that looks like. I'm going to take this equation, 3x minus 2y equals 14. Now watch, 3. Now instead of writing x, what am I going to plug in? I'm plugging in 2. Why? Because that's my x value. I'm checking to see if it works. Okay, minus, look, I'm copying this equation, 2, but instead of y, I'm going to put -4. Right here, this says -2 times y. I'm writing -2 times -4 equals 14. Okay, so notice what I did. I just copied that equation exactly, but instead of the x, I put my 2, and instead of the y, I put my -4. Okay, now I'm going to do the math, right? This is just order of operations. This is multiplication, this is subtraction, this is multiplication. We do multiplication first. 3 times 2 is 6. Negative times negative is positive, right? This is -2 times -4. So negative times negative is positive. 2 times 4 is 8. Equals 14. Now what's 6 plus 8? Well, 6 plus 8 is 14. So I get 14 equals 14. And hey, that is true. And look what I do. Put a little check mark on it, just so I can kind of keep track of it in my head. Okay. Now, remember, I plugged it into the first equation, but remember, I have to plug it into both equations. It has to make both equations true. So far, I know that this point is a solution to this equation. That means if I were to graph this line, the point 2, -4 would be on the line. However, I still don't know if it's a solution to this equation. So I'm going to do the same thing. 5. This is 5x. That says 5 times x. I'm going to make it 5 times. I'm plugging in 2. Plus 4 times y times -4 equals 6. Okay, again, I copied this equation, but I changed, instead of x, I wrote 2, and instead of y, I wrote -4, because that is the point that I'm checking. Okay, so let's go ahead and do the math. 5 times 2 is 10. This is positive times negative, that's negative. 4 times 4 is 16. 10 minus 16, is that 6? Let's see. So 16 minus 10 is 6, but 10 minus 16, where I'm taking away the larger number, that's -6. Does -6 equal 6? Nope. Okay, so notice this point is not a solution to both equations. It's a solution to this equation, but it is not a solution to this equation. So what's the answer to my question? Is 2, -4 a solution to this system? No, it's not, right? In order to be a solution to the system, it has to be a solution to both equations, and it wasn't. Okay, let's take a look at one more example, and then it'll be your chance to give this a go. Okay, now notice here I had 2 equations. These are both in standard form, a number times x, number times y equals a number. Okay, this next one I'm going to have 2 equations in slope-intercept form. The procedure is exactly the same, but it just ends up kind of solving out just a tiny bit different, just because the equations look a little bit different. Is -6, 5 a solution to, here's my system, y equals -2x minus 7, y equals 1/2 x plus 8. Okay, so once again, I have a y value. I'll put the y value in blue. Okay, my y is in a slope-intercept form. It's over here by itself on the left. My x value is -6. I'm going to be plugging that in for x. Okay, let's do the first one first. So I'm going to use this one, y equals -2x minus 7. So I'm going to do y, that's 5, equals -2 times x minus 7, right? Y. So here's the y in the equation. I plugged in my y value, 5. And then here's the x value in my equation. That's -2 times x. So I put -2 times -6. Okay, let's do the math now. Right, over here there's nothing to simplify because it's by itself on one side of the equal sign. Over here, however, there is some multiplication and there's some subtraction. We know that we do multiplication first. So I'm going to bring down 5 equals -2 times -6. Negative times negative is positive. 2 times 6 is 12. Okay, and then I'm going to bring down the 5 again. 12 minus 7 is 5. So hey, that is a true equation. Let's check the other one. Okay, so here I'm plugging in, let's see, y equals, so I'm plugging in 5 for y. Y equals 1/2 times x, so I'm doing 1/2 times -6 plus 8. Okay, again, I have plugged in 5 where I saw the y, and I've plugged in -6 where I saw the x. Okay, now the first thing I have to do here is multiply a fraction times a whole number. Okay, watch what I'm going to do. I'm going to shift, and I'm on page 105, so I'm right next to my example here. But you're not going to need all of page 105 for the practice problems. So what I'm going to do is I'm going to just, so I have some space, multiplying a fraction by a number. We've seen this before, but maybe you forgot, which would be okay. Okay. So in this case, I'm multiplying a fraction by the number, and what I'm trying to do is multiply the problem that I'm trying to do is I have 1/2 times, right, times -6. Okay, these parentheses mean times, so I can use the multiplication dot, that's not wrong, but this is what my problem looks like, 1/2 times -6. Okay, so my first step that I'm going to do if I want to multiply a fraction by the whole number is I'm going to make the whole number into a fraction. Okay, and how do I do that? I take the number and I put it over 1, right? Whatever my number is, my whole number, I take it and I put it over 1, right? Because like, let's say this is 10 divided by 1, so that's the same. So I'm going to take my fraction, just bring it down. Now I'm going to take my whole number and I'm going to switch to the dot just because it makes it easier to see. I'm going to make this over 1. Okay, so I made it into a fraction. Okay, my next step is I'm going to multiply across the top and the bottom. Okay, so let's multiply across. So 1 times -6 is -6, right? I'm multiplying across. 2 times 1 is 2. So I multiplied across and across. Okay, and then my last step is to just do this division. Is to just divide. So this is -6 divided by 2. That's negative divided by positive is negative. 6 divided by 2 is 3. Okay, so those are your steps if you ever need to multiply a whole number times a fraction, right? You make the whole number into a fraction, multiply across the top and the bottom, and then divide. Okay, so you have that on page 105. I'm going to shift back over here. I've done this math. This is 1/2 times -6 turned out to be -3. So I'm going to come and bring that back over here. I did this multiplication. And I'm going to bring everything else down, right? I bring down 5. I did this multiplication. I got -3. Now this says -3 plus 8. That's the same as 8 minus 3, which is 5. So I get 5 equals 5. That is a true equation. And the answer is yes. This is a solution. If I were to graph these two lines, I would find that the point where they intersect, the point that's on both of the lines, is this point here, -6, 5. Okay, it's going to be your turn now. Okay, and you can use page 105 for practice, right? There's a little bit of notes on the bottom, but you can use the top part of 105, and then you can also use all of 106 for your practice.